Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is converting types by manual casting. Before proceeding, make sure that you have already watched these other videos first. In C++, every expression has some particular type. The programmer is able to manually convert it into some other type by casting it. In traditional C syntax, you programmed a cast by writing the new type within parentheses before the expression that you're converting. More modern C++ syntax uses a templated static cast function instead. A lot of the time, you don't actually need to do a casting, because if you're ever in a situation where the type needs to change and coercion between those two types is possible, then you could just skip casting and rely on the compiler to do the conversion work with its coercion for you. Our previous video demonstrated the danger of overflow occurring during coercion if the new integer type's range of values is narrower than the existing type. That same overflow danger still exists when you're casting. One advantage of the newer C++ syntax involves casting between pointer types. Doing that is unsafe if the pointer types are not compatible with each other. Traditional C syntax would allow the resultant runtime error, but C++'s syntax prevents that at compile time. When C++ software has inheritance, a pointer to an object can be explicitly cast into its base class pointer. The result of this casting is a sub-object that can only refer to features of the base class. The pointer to object can also be implicitly coerced into that base class pointer, if that's unambiguous and protectedness allows it. A reference to an object has that same conversion ability. After you have converted something into its base class pointer, you could cast back into the complete object. Doing that always will compile, but it's only safe to do if you know that the object had indeed been allocated as the derived type of object. But if you do not know for sure whether or not the object had originally been allocated as a derived type of object, then use dynamic cast instead of static cast. This dynamic cast does a runtime check, and it returns null if the object had not been allocated as CR derived. But one catch of using dynamic cast is that it will only compile if it is casting between pointers or references of polymorphic inheritance. In particular, it will never compile for any primitive type. You could also use dynamic cast on a reference. For a reference, instead of returning null, a bad cast exception is thrown. If you need to add or remove const from a type, then either use C syntax or else use const cast. The basic type should not be changed when you do this. To reinterpret the meaning of an integer's bits versus a pointer's bits without actually doing any form of conversion between them, use reinterpret cast. However, the result of that will have no meaning until it is cast back into the original type.